Awesome. Thank you, everyone, for joining us today.
Tutu, hello, hello, hello. Hi, everybody who's stuck around. Welcome to this session. I'm Allison Baker. I'm a solutions architect in the retail vertical, and I'm here today. I'm going to introduce 3 speakers. Today we're going to unlock the next evolution of modern data stack with the Lakehouse revolution. And we're going to hear from Roberto Salcido. He's a senior solutions architect, and he's been with Databricks for about 2.5 years. He's very passionate about enabling analysts and data scientists to unlock the value of their data. And before joining Databricks, he was at a company called Mode, who is a BI solution. And in his free time, he enjoys hiking and watching sports. What sport? That's very generic. So basketball. Okay, so you watched all of the playoffs, I assume. Yes, okay. And then we'll hear from Kyle Hale. So Kyle, he's a senior product specialist, and he's been with us for about 2 years. And he says that his superpower is his endless supply of curiosity. And before he was at Databricks, he was a lead AI solutions analyst at, led AI solutions at Avanade. And starting off, we'll hear from Franco Patano. He is one of our lead product specialists. He's been here for about 5 years. And prior to being with Databricks, he was with JLL, their commercial real estate management company. And in his free time, he enjoys DJing under the name Za Vinci. And he enjoys making pizza from scratch. And he'll tell you all about it, too. So please give a warm welcome. Franco's going to kick us off. Thank you.
Thanks for those awesome introductions. How about a hand for Allison? Thanks for joining us today. I really appreciate you all sticking it out here the last day of the conference and catching our talk. Really appreciate it. To all you people out there streaming, thanks for tuning in. We appreciate you. We're here to talk about unlocking the next evolution of the modern data stack with the Lakehouse revolution. Did ChatGPT create this title? What do you think? Before we get started, I just want to kind of start this off by saying that this talk is for informational purposes only. Anything that we talk about are products. You shouldn't use those to make decisions, and the rest of the legal gobbledygook they make us put up here on these slides. Just keep in mind that this is for informational purposes only. So before we get started, I kind of want to set the stage, because we hear a lot of these generic terms: modern data stack, data platform, data warehouse. I just want to kind of set the stage of what we're talking about in reality. So when I talk to customers about what they want out of their data platform, in general, we can bucket them into these categories. First and foremost, they need to have security. If my data is not secure, you're not going to manage it, period. And then they want data governance. Data governance, though, is not the data police. Data governance is the data enablers. They're making sure that your data is getting out to the people that need to use it to do their jobs. And they're making sure that they do it in an appropriate way, they have access to what they need, and they can audit what they need. And then self-service. My users have to be able to take all this data that we have in our system, and they have to be able to use it so that they can answer questions for the business, or serve it up to, or do what they need to do to get the answers in the business decision makers' hands, so that they can do what they need to do to get the job done. And then underneath the covers, there's all these other things that have to happen with data in order to enable those use cases. Essentially, the first part is ETL. I need to get the data out of the systems that are producing it, and I need to transform it and load it into a way that can be queried by BI tools or by other tools. This is traditionally called ETL. There's another thing called ELT. I'll talk about that in a slide. But essentially, then you need it to persist this data. You have to persist it to some type of storage layer. This was disks, this was SANs, along came warehouse, along came data lake, and then now we're talking about this Lakehouse thing. But basically, you just think of it as a persistence layer. And then you have to actually do stuff with the data. You've got to find that value. You need to do data science, machine learning. Maybe you want to put some artificial intelligence, or now all the LLMs are all the rage. And you need to find value using machine learning and get that out of the data. And then you need to serve that value that you found up to your users. This is like BI serving, or analytics, or self-service analytics, or visualizations, or even machine learning serving, or real-time inference serving. Basically, we need to take all that awesome stuff we found and now get it into the hands of our users so they can get that value and put it into the business. So I also want to talk about a little bit about what is data warehousing ETL. Essentially, there are two major paradigms to get data out of source systems and into the warehouse form. The first one was ETL. You paid companies like Informatica, Ab initio, Talend, and the like because they had transformation optimized software that would transform the data and load it into a warehouse. But sometimes people got crafty, and because Informatica is ungodly expensive, they're like, can we cut that part out of the equation? And some crafty warehouse engineers were like, yeah, we just extract flat files out of the source system, load it into the warehouse. I just saved us $1 million off Informatica, and maybe we spent another $500,000 on the warehouse server to make up for that. You just netted $500,000, you know, that makes sense. But on-prem, you own the hardware, you bought the hardware, or maybe you rented it, like in a colo or something. But you owned the network, meaning you didn't have to pay per bit switched, you didn't have to pay per cycle computed, and you didn't have to pay per byte stored. All of a sudden, when you take ELT and you put it into the cloud, customers' costs skyrocket, and they're like, what happened? That's because the warehouse was not built to do transformations, and ELT is actually a really poor anti-pattern in the cloud because you're using the most expensive compute, which is the warehouse compute, to do the most expensive job. And then finally, after you've gotten the data out of the source systems and put it into the tables, you now need to serve this data up, and this is like the presentation layer. This is the squeaky wheel in the entire paradigm, because if your data, if serving is slow, your users are going to complain. If your users complain, the whole thing is in shambles, right? So we normally see everyone over-index on the serving layer, but nobody really looks at the ETL. We haven't. Nobody hasn't before, but we're going to take a look at that today a little bit. Let's talk about data warehousing, the evolution of them over time. In the beginning, there were hardware, servers, and you had to license the software, and some poor DBA had to go figure out how to take the warehouse software, put it on the server, configure it, and 6 months later, birth the warehouse. And then these warehouse companies got together, and they're like, you know, what if we just put it all together? We'll make appliances. We'll put the hardware, software, we'll tune it, we'll make everything, and then we'll sell it to you at a premium. This was really expensive, but people bought it because it was great. It was simple for their DBAs, and they implemented it. And then along came these cloud data warehouses, and they thought, hey, we're going to take these premium data warehouses in a box, toss it into the cloud, and we're going to charge them per cycle. It's going to be great. And these are, unfortunately, really, really expensive in the cloud, and the costs end up being uncontrolled when we see customers put those things into production. So why can't you use a cloud data warehouse as a modern data platform? Again, the costs go out of control. We see ELT paradigms 6x the type of traditional cost that we would normally do ETL for. Customers are overpaying these cloud data warehouses to do. The cloud data warehouses were not meant to do streaming. They weren't built to do unstructured data. Some have forced semi-structured into them, but they're sometimes inefficient, or it takes a lot of compute. The governance patterns are not compatible. Files are secured by directories. Warehouse tables are secured by tables. You can do fine-grained access controls. And then finally, you have to copy your data multiple times. You land your data on object store, S3, ADLS, or GCS. You have to put it in the warehouse. And then if you want to do data science, you've got to take it back out of the warehouse, put it back on object store. 3 copies of your data? Statistica says data volumes are growing at about 20% year over year. Can your business afford to keep 3 copies, 20% compounded year over year? Most people don't think they can. So when we come into an organization and they're like, can you help us? What we find is that they've been sold these various tools over the decades. Somebody came in and sold them on-prem databases. And then along came these enterprise data warehouses. And they said, no, you need a data warehouse. And then along came Hadoop and said, no. Hadoop is so much better because it's cheap storage. Throw all your data there, and you could do some machine learning. And then came the data swamps. And then finally, these cloud data warehouses came along and said, no, you have to use a cloud data warehouse, and we're going to give you the best BI performance. And now you have another vendor, and your architecture has become really complicated. People are like, is this it? Is this the future? We don't think so. Why does all this matter? Who cares? When we help customers evaluate their options in the cloud, what we find is, statistically, we find up to 70% or a little bit more of their costs are with ETL or ELT. And you need ETL. It's how your data gets from source A to point B, right? You can't do anything without it. And the industry itself over-indexes on TPCDS for query serving. This has actually aggravated me for a really long time. No one benchmarks ETL, orchestration, or data quality. And these are like the most important parts of your business. Like, query serving is important because it's the squeaky wheel, but the most expensive part is ETL. So I'd like to talk to you all about TPCDI, which is the industry standard benchmark to do ETL, orchestration, and data quality. What is this thing? Basically, it's a benchmark that simulates transactional systems that you have, that organizations would have, and it produces flat files. Then you then have to transform all of those flat file data into a data warehouse-like representation. It's almost a 120-page document of business requirements to build a data warehouse. It's really long. Not even my worst enemy, I would tell you to go read this thing, although some of my best friends, I've put it on them. What are we doing? So it all depends on the table. You get all these different types of files that come from these simulated source systems. You get CSV files, you get semi-structured text in XML, you get unstructured text documents from like a newswire type feed. You have to take all this data from those flat files, transform them given the requirements in the business requirements document, and build a data warehouse. There's some SCD type 2 with CDC. There's unstructured text data. There's advanced transformations like Windows functions. It's got a little bit of everything that organizations need to do with their data to prepare a warehouse. This is a little bit of what the data model looks like. You get some incremental fact tables that need to be processed, and then you have history tracking on your dimension tables. And essentially, it keeps, you build a real data warehouse through these capabilities. But what about concurrency? I'd like to bring up my colleague, Kyle Hale, to talk to you about concurrency.
Thanks, Franco. So what about concurrency? Forget about it. OK, so if you take one thing away from this besides the awesome work that Roberto and the team have done on TPCDI, it's the right way to measure performance is not concurrency. The right way to measure performance is latency and throughput. So you should be asking all your vendors, including your Databricks SAs and field teams, how long is it going to take for my workload to finish? That's measured in time. That's latency. That matters to users. You don't care if there's 1,000 users sitting right beside you hitting the same workspace, warehouse, BI report. You want yours to run fast. That's latency. Throughput. How much of my workload can the system complete in a unit of time? This is queries per time. This is everybody coming in. And how much can we push through the system in a fixed amount of time? This matters to admins and people who are paying the bills. Right? Because at the end of the day, you want your workloads to be very efficient for throughput. When a lot of users come, spin up a lot of clusters to get them through quickly, and then spin back down. Concurrency, on the other hand, is just an input. Just how many queries can the system process at the same time? Well, it's literally just, you can put as infinite concurrency. You can throw as many queries as you want at a system. It doesn't tell you how it's going to perform in terms of latency and throughput. Concurrency itself is kind of a red herring. Measured in queries, doesn't really matter to anybody. Latency and throughput. If you take one thing away, these are the things you should be focusing on. That's what we're going to focus on for the rest of this portion of the chat. All right. The cashier curve. So first, a big shout out to our customer, Ahold Delhaize. So Shannon's laughing at me already. Good. So this is the real truth, though. Like, the way you should think about serverless offerings and scalable offerings in the cloud, including ours, is like a cashier at the grocery store. Right? You go into the grocery store. You start with one cashier open on a sunny, kind of open normal day, and then you have a rush. Right? You have an afternoon rush. Maybe you have an evening rush. And what happens? They add more cashiers to handle the load. And that's really exactly how serverless works as well. So and so we're talking about latency and throughput, right? So you obviously want each of your individual customers to come through the cashiers as quickly as possible, and you want your total set of customers to be able to come through the entire set as quickly as possible. And then more importantly, when all that rush dies down, you want to be able to, again, close all those stalls and go back to that one cashier waiting for your one open customer, right? That's the cashier curve. And really, the ultimate goal of any system that's trying to serve serverless piece around latency and throughput is to maximize utilization of the cashiers while minimizing the actual number of cashiers you need, right? So like, if we can really get the exact workload shape, just basically supply and demand, the exact amount of demand for queries coming in can be met by the exact amount of supply just in time, that's going to be 100% utilization. That's the best you can do. Honestly, no warehouse vendor does that today. We don't do it today, but we aspire to that, as everybody should. So keep this in mind as we're going to the next slide, because when we talk about now that we have this kind of strategy for dealing with latency and throughput, again, we're going to kind of use the grocery store cashier model, intelligent upscaling, right? So being able to actually bring on more cashiers because you know more queries are coming in of a certain type. You can actually like have your cashiers ready for when those people hit the queue, right? So when people enter your store, you kind of start to see what's going on. You bring those cashiers before they hit the line. Intelligent upscaling, wow, that's fast. That means that each individual person gets assigned resources for their queries and doesn't have to worry about the overall performance, right? You just know that your particular query is going to be executed as fast as possible. Concurrency boost, reduced queuing, right? So this means just advanced load balancing. And what this really means is that for a certain period of time, maybe I've got 2 cashiers working a particular aisle when things are heavy or there's a lot of things coming in to move that particular piece faster, right? So just having an extra spare bit of compute that can go run around and serve up those different clusters to give you a little bit of extra boost when there's just a little bit of, especially in that time period between when you're scaling up to new clusters. Intelligent downscaling, lower TCO. That's what I talked about at the end. So when your rush is done, we want to be able to, as quickly as possible, reduce those cashiers. So that sometimes means you combine your resources back into clusters and get rid of them early, and being very aggressive about this in a scale down algorithm. So again, at the end of the day, we're trying to lower TCO and maximize utilization. So we have one machine working at 50%, another machine working at 50%. Let's just kill one and make another machine work at 100%. That's the idea. Last is real-time cluster evaluation, bin packing that utilization. Again, utilization is really kind of the culmination of latency and throughput. It means that we're really trying to make sure that the supply of clusters, because we could just spin up a cluster for every query, but it'd be wildly expensive and inefficient. You'd have a lot of lack of utilization. So bin packing all those queries into the clusters you have, and then preparing for, again, scale up and scale down, and doing that as intelligently as possible. So we do that in real time now. And really what this means is that we can have a very dynamic approach to scaling up and scaling down on our clusters to try to hit that 100% utilization. Don't think we're ever going to quite get there, but that's really the goal, is to be as intelligent as possible about it. The ways that we typically test this, we talked about TPCDI earlier. TPCDS, by contrast, is a much more popular standard. It's been around forever. Everybody uses it. That's where our world record benchmark came from, is from TPCDS. So this is the workload that we typically use to test all of these pieces. If you don't know anything about it, it's essentially just a decision support system. It's a dimensional model that's already been built. There's a bunch of queries that they provide you out of the box that you're supposed to run cold and then warm and then concurrently and so on and so forth. Again, this is just a really great standard to go test any other vendor's warehouse and query serving platform against Databricks or anybody else. OK, but what about concurrency? So everybody just keeps asking, like it doesn't go away. So can Databricks SQL Warehouse handle concurrency demands? So what I want you to focus on is obviously both parts, but the part at the bottom is the cashier curve. So this is us bringing on clusters online to meet demand. So the thing at the top is the demand, and the thing at the bottom is the supply. So in this case, what we're doing is we're running TPCDS queries in parallel. We're running lots of them. We actually ran about, as you can see in each one of these batch runs, about 2,000 queries, all submitted simultaneously, concurrently. And this is how our system handles it. It first starts, we have a baseline of 3 clusters in this environment. So we start with this, and then we realize very quickly, as you can kind of see, that it's not going to be sufficient to reach, as we get those first 700, 800 queries in, it realizes, oh, I need more clusters. So you can see that it stair steps up, opens more lanes in the cashier analogy that we're working with, delivers all of those, and then there's a pause, right? We paused our test. And you'll notice that the thing stays at 7 clusters in this case. It can actually, maximum can go up to 30. But in this case, it stays at 7, and it waits. And it waits because it doesn't know right now intelligently. It thinks there's going to be more workload like this. So it sticks around. Sure enough, it's right, because we spin up another concurrency test as soon as this one's finished. So then we run a bunch more. Now it's ready at the 7. And we see that actually it figures out, hey, I actually don't even need one of those clusters. So we go from 7 down to 6, right? Excuse me. Sorry. So we go from 7 down to 6 clusters, and then it finishes out the rest of the test. And then again, it sits around for just a little bit, right? You leave your caches open, you don't quite know what's going on. But after about 5 minutes, you'll see right there at the 17 o'clock mark, 5 p.m. mark, it says, OK, fine, we're good. And we start to slowly stair step down, it goes back to the steady state of 3 clusters. That's the cashier curve. You'll notice that everything under that curve, and this is what we were talking about, that's what you paid for. Because the steady state you're already paying for, right? That's just the price of having a cluster on to be served even the first query. That's the one cashier open. But in this case, everything above that curve, that's the spike that you paid for. And if you actually do the math on this is about $28 of extra compute. Now, the alternative to this is you stayed flat at 3 clusters, right? You spend at 3 and you don't scale, or you scale very conservatively. And in that case, yeah, you didn't spend $28 for this extra compute, but you know what you did instead? You queued up all these workers. These simultaneous workers who came and brought their queries in, they just sit and wait. And those people get paid too. They have actual, they have wages. They have lost wages based on this. The opportunity cost for essentially having thousands of users or hundreds of users waiting for their queries versus $28 compute is the pure definition of penny wise and pound foolish. And in this case, we want to have those cashiers open, so that's how serverless works. OK, so now I'm going to turn it over to Roberto to talk about beyond the modern data stack.
Yes. OK, perfect. Thanks. Yeah, I know it's kind of complicated. We're switching a lot, but appreciate that. OK, great. We're about halfway through, folks. So I know most of you are actually here for the partner-led demos. So we'll try to make this brief, try to leave 15 minutes to actually dive deep into these platforms. But yeah, what exactly is the modern data stack? Well, you could think of the modern data stack as essentially like best-in-class tools to handle SQL-based ingestion, SQL-based transformation, and SQL-based presentation layer, analytical layer, right? All using best-in-class tools and all pushing down compute to a cloud data warehouse or cloud data lakehouse. So really great paradigm, kind of a logical extension of the on-prem kind of challenges that Franco was talking about earlier. So all these tools, purpose-built for the cloud, purpose-built to take advantage of everything the cloud has to offer from both a simplicity perspective, performance perspective, and cost perspective. Now to dive deeper into the actual tools that are part of the modern data stack. So obviously from an ingestion perspective, right, one of the best known is a very close partner of ours, Fivetran. So basically a tool that allows you to take all your data from third-party apps, from OLTP systems, and get those into the Lakehouse or warehouse, meant to be very simple, very scalable, et cetera. So great tool. If you use Databricks, go to Partner Connect, can hopefully create a Fivetran free trial and do that whole process in under 5-7 minutes, fully integrated within kind of like the Databricks offering. And then from a transformation perspective, obviously another very common tool out there is dbt. So from the perspective of a declarative ETL tool that can handle data quality, data lineage, data discovery, dbt is obviously best in class, and also very seamless integration with Databricks for both dbt core and primarily dbt cloud as well. So we'll be talking, that's how we were able to run the benchmark. One of the great things about dbt is it's pretty warehouse agnostic. So we're able to take the TP-CDI code, build it on dbt Databricks, right, because we have a very tight integration with them, and then make some slight modifications to the logic, get it to run in 3 other single cloud data warehouses and 1 multi-cloud data warehouses. I can't say any of the names, but those are the different systems that we ran it in, and we'll have some compelling results there in a bit. And then obviously Tableau, and just the analytical layer in general, very critical part of the modern data stack, and again, very, very tight, seamless partnerships that we have with those tools. And then when we say beyond the modern data stack, this notion of this talk. So basically what this vision offers is obviously the foundation of the modern data stack is SQL-based ingestion, ETL, BI, et cetera. So obviously, that's a must-have, right? You have to have a tool that can handle those workloads and handle those well. So what we're trying to aim for, elevate the conversation, is to be kind of a trifecta. So be able to run those workloads, be able to run them super cheaply, right? Especially in this economic climate. I'm sure cost is always top of mind in every conversation we're having with customers. So run your SQL-based ETL, run it cheaply in a TCL perspective, and have additional AI capabilities, unstructured data capabilities, streaming capabilities that, even if it's not top of mind for your business now, could very well be 6 months down the road, 9 months down the road, et cetera, and just having a future-proof platform that will be able to accommodate those workloads in the future. I'm not sure if you all saw, I believe yesterday, we announced support of dbt and Databricks for streaming tables, right? Franco made that announcement, I believe, or was involved in that for materialized views. So being able to run those streaming jobs directly through kind of like the dbt declarative framework, super big, super important. So it's definitely something I would encourage you all to try out. And I think with that, hand it off to Franco to introduce the demos that we're about to get.
So don't click. Right there. All right, everybody. Welcome to the real world. You take the red pill, and you stay in Lakehouse, and we show you how deep the modern data stack goes. You take the blue pill, the story ends. You wake up in your cloud data warehouse, and you believe whatever it is they tell you to believe. Remember, All we're offering you is the truth, nothing more. For those of you that stayed, buckle your seatbelt, Dorothy, because warehouse is going bye-bye. It's demo time. Let's get started. I've done it before at Databricks, so it's pretty fun. All right, so I'm going to just rearrange these things real quick. Where's the other screen? Got it, thank you. All right. Sorry, just switching around here.
Bottom right corner.
Thank you. All right. So where are we going to get started first? First, it's Fivetran. So Fivetran has a great capability to connect to virtually any data source. For TPCDI, we get all those flat files. It doesn't really come off of a source system. So here, I just created a Google Drive folder that had all this data, and this is what that looks like. In order to ingest in Fivetran, all the files needed to be refactored because each directory would go to one table. So what I'm going to do here is I'm going to show you how we do that. So I'm going to take my directory that I have these files in Fivetran. I'm going to go ahead and set up a new connector. You see, I've already set up a lot of these connectors for this tool. I'm just going to go, for demo purposes, show you how this works. It's super simple. In Fivetran, you just give it the destination schema. Here, I'm going to have this data go to TPCDI cache transaction, because that's the name of the table. And then I'm going to give it that folder from Google Drive, and I'm going to go ahead and save that. And then what Fivetran is going to do is it's going to incrementally process data off of that Google Drive and ingest it into the SQL warehouse. This is awesome. I just set it up once, set up that sync to start, and the data is going to flow into my warehouse. That's awesome. So all of my data that's coming from those flat files, I can ingest it all with Fivetran. So this is that first step. So all of that data is now going to be coming in through Fivetran. And then what we need to do is transformations with dbt. So I'm going to bring Roberto back up here to show you how to use dbt Cloud to do those transformations. Roberto?
Awesome. Thank you, Franco. OK, great. So now that the data is in the warehouse, in the lakehouse, right, the next step is to actually transform it and cleanse it. And as Franco was saying, this is typically the most expensive and a lot of times the most complicated part, right, is actually transforming really big data and creating your marts and your aggregated tables that you then serve up to the business with Tableau, Looker, et cetera. So to demonstrate this is going to show dbt Cloud, and specifically the underlying hardware is going to be a serverless SQL warehouse. OK, great. So this is a dbt Cloud UI here. And definitely what we feel is the best place to handle your development workloads for dbt as well as your productionalization as well. So let's go ahead and first talk about the backend infrastructure. So you have a few different options with Databricks. This particular pipeline leverages serverless warehouse, and we were able to get the best actual TCO. Running tests on the serverless warehouse, so certainly a very common pattern that we see is partnering dbt with serverless SQL compute. And if you're using dbt core or dbt Cloud, you can look at the connection details tab. And then basically you're going to need the host name. You're going to need the HTTP path. And then a token to instantiate the connection, and then finally just the schema that you're going to be writing to. So obviously dbt Cloud being a managed service, that's all handled with the account settings and the profile settings here. So we set up this particular project, dbt TPCDI. And then as you can see, I connected my Git repo here, and I have this connection, which is just taking these connection details and inputting them into the dbt Cloud UI. And then from an individual perspective, right, if I go to my personal or my credentials here, that's where I go ahead and put my token and say which schema that I want to write to, right? So for development, it's fine. I just have a schema named, with my initials, my own little kind of like staging dev little environment, right? In production, we can actually write to actual proper staging production schemas. So you can do that, obviously, with the capability dbt Cloud has around jobs and run history. So certainly would encourage you to create an environment that actually uses a service principal, ideally, to go ahead and build your production models and to go ahead and write those to your production schemas. And then the true trifecta is if you add Unity Catalog in there. So dbt, Unity Catalog serverless, That's really the direction that a lot of our most kind of mature customers tend to follow those patterns. So lots of really neat capabilities around productionalization of DBT jobs within DBT Cloud, right? And then also from a development perspective, also really neat, really cool capabilities as well. So we can go ahead and talk. Let me just revert these changes. OK, great. Yeah, we can go ahead and talk about the actual nuts and bolts or meat and potatoes of how this kind of TPCDI framework fits within kind of like the whole DBT kind of repo version control software engineering best practices based kind of model building framework. So as you can see, very standard DBT implementation. I have obviously the models, which is where all my SQL code lives, and I have a bunch of different YAML files that control kind of like the configuration of how I instantiate my model builds. So if we want to just look at the repos here, we have a standard, our project YAML, right? The only variable we really use is the benchmark size. So this benchmark is 10, 100, 1,000, and 10,000. We chose 1,000 benchmark here because that's 10 gigabytes or 100 gigabytes. The others are either 10 gigabytes or 1 gigabyte, which isn't really emblematic of production load. And then there's 10,000, which is like a terabyte. So we just stuck with 1,000, but we set up the code such that it's parameterized and can be run with the full suite of benchmarks that TPCDI offers. And then packages YAML, we rely on pretty standard DBT utils, Spark utils, and then DBT external tables. Really nifty little package for essentially creating raw views off raw data that exists in S3, right, or GS or ADLS, CSV files, Parquet files, JSON files, things like that. And then we have those raw views, we read that raw data, and then build our downstream silver and gold tables. So that's the way we structured this particular implementation. As you can see in the models repo here, there's a bunch of base tables that we build. Those are essentially the raw views or enriched raw views. And then the sources YAML is where we kind of fetch all the raw data. We're saying where in S3 do those files live? Do we use CSV? Most of the files for TPCDI are text delimited, pipe delimited CSV files. And then we can obviously set our header. So it's pretty long. It's over 1,000 lines. But this is all open source. You can take it and run it yourself. In fact, we encourage you to do so. So we'll include the GitHub link there, but it's open source. You can go ahead and just DBT stage external sources and then DBT run. All the information, all the setup is in the README files. So we have our base, we have our incremental, and our silver. One particular base table here is customer, let's say customer incremental. Right, so the really neat thing about DBT Cloud, obviously we have our SQL script here, right? It's just unioning a bunch of views, essentially, enriching it with a batch ID. But you can see the lineage, super neat. You can see what's upstream is my raw views from the sources YAML. Downstream, I have my dimension tables, and it ends with the dimension customer. I can also adjust it, so if I wanted to see further upstream or downstream, I can go ahead and update the graph. Pretty neat, so really cool from like a data discovery perspective, data lineage perspective, right? Obviously, for data quality, we have tests, but we didn't really set up a bunch of tests for this particular pipeline. So there's other neat capabilities. You can preview, just fetch the results for the first 50, 100 rows or whatever. You can compile. So obviously, DBT, you use a lot of like refs, some sources. You invoke a lot of macros, right? Really great for parameterizing and scaling out your code. But sometimes you forget what all the different things mean. So when I'm reading from this source under TPCDI called customer incremental, I can actually see the compilation. So what does that actually mean? Well, here's my catalog. As you see, this is high metastore. We would have used Unity, but that's a longer story. That's a long-term vision. Here's our schema here, and then here's our particular tables. And then the neat thing also about DBT Cloud is it's UI-based. So rather than, of course, there's a lot of DBT shell commands you can run, right? DBT run, DBT build, et cetera. But this just, if you happen to forget the shell command or want it to be kind of just a subset of tables, it's easy to just pick here. So in this case, we're going to be running the model, so it'd be DBT run. And then a few other neat things. You can look at, obviously, code quality, right? If I wanted to go ahead and format it differently, lineage, et cetera. So really neat. Really encourage you all to play around and try it out. So the main thing for our purposes, what we're going to be doing is just running the code. So in this case, DBT run. Go ahead. We're not actually going to wait for it to entirely run, but we can again rerun. And then we get a sense for what that experience is like. As you can see, I had some previous runs, right? And then there's 27 tables that get built. They all passed. Good news for us. And then we can see for each individual table how long that particular model took to build. So Yeah, we'll go over some results later, and particularly some really compelling things from a TCO perspective, but certainly here's what the experience is like in dbt Cloud, and certainly encourage you all to try it out with this particular pipeline or your own production pipelines. So in that vein, I'll go ahead and pass it back to Kyle to switch out his computer and talk about Tableau.
All right. So really quickly, for those of you who don't know Tableau, Tableau is one of our great partners. They've been around for forever, been one of the leading visualization and BI tools out there. Lots of customers use it, really happy. So I want to tell you just really quick about like how it kind of works with Databricks. So inside Databricks, or inside Tableau, sorry, you can connect to Databricks as a native connector. So we offer a native connector there. You can connect with both personal access tokens or PAT tokens as well as OAuth. So it's really convenient if you have a security model around it. And we'll work both with Tableau Server, Tableau Cloud, as well as Tableau Desktop, which is what we're demoing today. So once you access that, then you've got this nice view where you can go and talk to whether it's Unity Catalog or the HMS. You can come and choose a catalog. From there, go into the databases, and then bring your tables in and create a data model inside Tableau. One performance tip that I always like to tell everybody is like, especially if you've got used a proper data model in here, is under the performance options down here is definitely make sure that you set your cardinalities and referential integrities right. So if you build a real dimensional model, you should be able to do inner joins between your dimensions and facts, and they should always be one-to-many. But the default in these is many-to-many and full outer joins, which is not as great as performance. So good performance tip right there. But that being said, so what we're going to do is like in the meantime, we're going to just kind of show what the experience is like. So we're going to switch gears really quickly to this concurrency test. So I mentioned earlier, we run this test with a bunch of TPCDS queries. This is what I do to actually run it. Actually run this, it's about 250 queries. Each one of these executes, and then I just execute them in 8 different threads. If you do the math, 8 times 250 is 2,000. So yeah. So we can see that we're actually kicking off a bunch of queries, and each one of these lines as they kind of get returned is a query that's being run against the Databricks instance that this same, this one right up here, that this connection is pointing to over here. So while this is running, we're going to come over here and just do a little bit of manipulation over here. And this is really just to kind of show you that, again, the only thing that matters is not those 2,000 queries I just kicked off. It's this user right here. It's me. I'm on Tableau. If it's slow for me, it's slow for everybody. I don't really care what's going on with everybody else. OK, so with that being said, I'm just going to come down here and just do some manipulation. So this is just a heat map of TPCDS by store. I just picked a random measure, not really too concerned about what the measure is, but in this case, we're going to go add a color to it. We added additional queries. And this is going to go kick off a query against Databricks SQL. Cool. All right, there. That's literally the demo. I can add more things if you'd like, but like the real thing here to just kind of take away is like, while over here, all these queries are running, this user doesn't care. This user wants low latency. We want high concurrency, so all of these users, you can imagine them, they're all getting their workloads done. Actually, if we go back and look kind of over on the backside, like what's happening on the warehouse, on this warehouse over here, we might not be able to see it in time. Actually, let me refresh the page and see if we can see it in time. We might not be able to have time to do it, just I didn't know exactly how I was going to plan out with the rest of the demo, so I might just turn it over to wrap this up. But you can kind of see already a little bit of spike, right? We've already moved from 3 to 4 clusters to support that concurrency. So that's that cashier curve, right? We're trying to assess what's going on over there in the background and start to bring some of those workers to bear to kind of make this concurrency work. So this is how our system works. And at the end of the day, we're trying to keep this where price performance, that's the name of the game. And we're really trying to shoot for is like, you as a user, you want low latency, your overall users want overall throughput, and you want it in the most cost-effective manner possible. That's utilization. That's how we do it. All right, cool. So that's the demo. All right, so now let me jump to the last slides and wrap up here. So, what's demo time? Yeah, I can roll back up. Yeah.
Last minute here. Drum roll. So again, caveat, run these for yourself. Code is open source. You're completely free to run and revalidate. We ran the benchmark against using dbt as a shared framework against Databricks, 3 single cloud data warehouses and a multi-cloud data warehouse. not going to say the names, but the results are here. I always joke that vendors never publish or showcase a benchmark that they don't win. Here, we violated that rule. Actually, we tied for the top slot, but as you can see, this is just the results we were able to see with the TPC-DOI 100 gigabytes of files. So go ahead, revalidate. We're also going to be publishing other charts as well, but this is the chart that's actually consistent with the benchmark as it's written, what the results were. So in the last 10 seconds, we are pretty much wrapped up.
We think the best data warehouse is a lakehouse because that provides you with the best price performance for ETL and query serving. And now we've proved that to the world with independently reproducible benchmarks of those very claims. You can reproduce these things yourself. We don't want you to believe us. We actually want you to go out there and try it so that you can discover Lakehouse today. If you want to get started, definitely check some of these resources out. We have some links here. I think it'll be shared later. If you want to check out this repo that we have this code in, take a quick snap of that QR code. It'll take you over to the repo where you can download it and try it for yourself. Code on how to run them on all the warehouses will be there soon.
Very soon.
We are still, in order to prepare for this talk, it was a race to the finish, so we didn't actually get
This took a lot of effort to do across all the warehouses, so we're wrapping it up.
And finally, there's one more. All right, and if you want to learn more at Summit, tell us what you think. Definitely rate it in the mobile app and get certified and trained. If you want to check out the app, check it out there. I think we're done.
That is
Done.
Awesome. So I don't think we have time for questions, but the three of us will be available back there if you want to talk to us.